All right. Physics is the study of the physical environment, covers matter and energy. So the first couple of chapters that we're going to get into is going to cover motion. You guys need to familiarize yourself with these fundamental quantities and SI units. Okay, so length is in meters, the mass is in kilograms, and the time is in seconds. All right, we went over conversions last time. Don't forget to try to become familiar with the prefixes, how to go back and forth between them. And let's see. Okay, we stopped before we got to measurements. All right, so anytime you take measurements, whether that's with a ruler, graduated cylinder, or a balance beam, or a scale, all right, those digits on there are letting you know the certainty of that measurement. Okay, sometimes there is going to be uncertainty because that's just how measurements are. All right, so right here on this slide, we have a wooden block and we have a ruler that says 10 here. So we're just gonna assume that this is 10 inches, okay? What will be your guesstimate? And you can either come on mic and say so, or you can type it in the chat. And let me open my chat while I'm talking about it. Open the chat. And let's see. Pull this up. Okay, what is your estimate of the length of this wooden block here? All you know, all you see is the number 10 on the end piece of this ruler right here. But what is your best guesstimate or estimate of the length of this wooden block?
6.5 inches.
All right, anybody else?
I was
Yeah.
thinking about 5.
All right, you guys are in the vicinity. All right, so now we have a few more number points on here. So we had a guesstimate of 6.5, which you're sort of kind of close, and 5. So you guys are in the ballpark range. So let's add some more lines to this ruler. All right, now what's your estimate or guesstimate?
6.4.
All right, so we keep getting closer and closer. The more lines we get on this ruler, the more accurate our number becomes. Okay, so that's where certainty and uncertainty in measurements come from. Okay, so here are the rules for significant digits. All right, all non-zero digits are significant. All right, 1 through 9 are significant. Any zeros that are between non-zero numbers are significant. So 1001, those 2 zeros in between, 1 and 1, those are significant. Zeros used to hold place value are not significant. And then number 4, all digits in a scientific notation are significant. We're also going to talk about analyzing data and graphs. So you'll need to know the difference between something that's directly proportional to something and inversely proportional to something. So directly proportional means that as one quantity increases, the other quantity will increase as well. All right. So that's when you have an independent variable and a dependent variable, and they're both doing the same thing at the same time. Inversely proportional is when you have your independent and dependent value, but they're doing the opposite at the same time. So as one quantity goes up, the other quantity goes down. All right. So on to dimensional analysis. All right, so we have physical quantities, and these are numbers that can be quantified dimensionally. with units. All right, so length has a unit, that's in meters. Time has a unit in seconds. Current, temperature, all of these have units. Okay. For dimensionless quantities, that means these are just numerical values. They're just numbers, but they don't have SI units. All right. So examples of dimensionless numbers that have no units are pi, which pi is 3.14, and a bunch of other numbers after it. Trig functions, those are dimensionless numbers, and log functions are dimensionless numbers.